Welcome to section 7.2, rational exponents. Alright, so we have three different things we're going to look at. One is the meaning of a to the 1 over nth power. And what does this mean? Well, if a is a real number, then what do we have? So if a is a real number, then a to the 1 over n equals the nth root of a. So for example, a to the half power would equal the square root of a. So the item that's on the bottom is going to be the index of your radical. Now let's take a look at the next one. Once again, if a is a real number, then am over n is going to equal a to the 1 over n raised to the nth power. Or, you can switch it around, a to the nth power to the nth power. An example for that would be, if we had a 3 over 2, that would be the square root of a to the third power, or that would be the square root of a to the third. So either one, doesn't matter which one comes first. And then the last one we have is very similar, except this time we have the negative. So once again, the same thing, if a is a real number. So if a, negative m over n, we're talking about the positive. If a of m over n is a real number, then a to the negative m over n is going to be equal to 1 over a to the m over n. So once again, just using the negative rule for radicals, you make the reciprocal to get the positive. Okay, so let's take a look at using these. Example 1, evaluate each exponential. So basically, evaluate means to just apply any of the operations you see. And for part A, what do we see? Well, we see 25, and it is raised to the 3 over 2 power. So there's two options we could do. We could go 25, raise it to the third power, because remember the 3 is the power, and this is a root. The one on the bottom is the root, one on the top is the power. That's sort of how you think of it in life, right? The person with the power is on the top, and the roots are in the bottom, right? Okay, so you could do that, and then take the square root of it. Let me move this over. Or, other option, we could take the square root of 25, and then raise it to the third power. Which one do you think would be easier? Well, I don't know about you, but I do not know what 25 to the third power is, and after that, I don't even know how to find the square root of that. You could use a calculator, but that's pretty massive if you're trying to do it by hand. However, I do know what the square root of 25 is, and then I'd probably be able to put that to the third power pretty easily. So I'm going to go with this method, and usually it's easier if you make things smaller before you make them bigger. As usual in math, if you can simplify, you should simplify. So let's follow that method. We'll root it and then square it, or cube it. So 25, 3 over 2, is going to equal the square root of 25 raised to the third power. Square root of 25 is 5. Raised to the third power, once again, 5 to the third power is 5 times 5 times 5 is 25. Bring down that other 5. That's 125. And we're done. A lot easier than trying to find 25 to the third power. So let's take a look at the next one. Ooh, interesting. We have a negative with the 64, which means the negative is going to be having all of that applied to it as well. Okay, so let's take a look. So we want to have, and as usual, I always go with the radical first, the square root of negative 64 to the third power. Okay, what's the square root of negative 64? What times itself gives me a negative number? Nothing times itself gives me a negative number. This is not a real number. So since this item right here, this concept, is not a real number, we can't continue. So what would our answer be? Our answer would just be, this is not a real number. So just state that. And we're done. Let's take a look at the next one. Once again, we have that negative, so you might be worried, but careful. This time the negative is not in the parentheses, which means it's technically outside because 4 is the base of those exponents. And the other one, negative 64 was the base, but this time just the 4 is the base and the negative is on the outside. So let's go ahead and apply this. So we have the square root of 4 raised to the 5th power. Now what is the square root of 4? Well, that's just 2. And then 2 to the 5th power, let's check that out. 2 times 2 times 2 times 2 times 2. That'll be 4. That'll be 4. Bring down that 2. That'll be 16. Bring down that other 2. 16 times 2 is 32. So we have the negative 32, which simplifies to negative 32. All right. Okay, so we've done that. Once again, be careful with the negatives. Ask yourself, what is the base of our exponent? Okay, let's take a look at the next ones. Ooh, interesting. This time the negative is in the exponent, which means we're going to need to use the reciprocal rule. So 4 to the negative 5 over 2 is actually going to be 1 over 4 to the positive 5 over 2. Okay, once again, when you have a negative in the exponent, it means the reciprocal. That's when it's in the exponent. All right, so let's go ahead and now work on the rest of the exponents. So because of the 2 in the denominator, that'll be the square root of 4, and then we raise it to the 5th power. We've already done that. That's 2 to the 5th power, which we know was 32 from the last problem. So it's 1 over 32. Okay, let's take a look at the next one. Ooh, look at that. Once again, we have that negative in the exponent, which means we're going to take the reciprocal. Oh, this one's a little sneaky. Because it's already a fraction and we're going to take a reciprocal of it, once again, reciprocal means we're going to be taking the flip of it, which is just going to be 25 over 64, now raised to the positive 3 over 2. The negative, we got rid of it because we took the reciprocal. So now it's positive. Rules of exponents. Okay, so then we're going to go ahead and use rules of exponents again and distribute that fractional exponent to the top and the bottom. So we get 3 over 2 on the top, and then 64, 3 over 2 in the bottom. And then what we get, once again, applying the root if we can, square root of 25 raised to the 5th power, all over the square root of 64 to the 5th power. Square root of 25 is 5. Still got to work with the 5th power. Square root of 64 is 6. Once again, still to the 5th power. Let's see. So, usually, if it's this high of a power, unless it's 2, I would ask you to just leave it at this. Depends on your teacher. For me, I'm fine. You can just leave it as 5 to the 5th and 6 to the 5th. Basically, once anything gets past the 3rd power, most of the time I don't ask you to multiply it out. Okay, and if you aren't certain, and you want to be very careful, you can just write, we were told, we can keep it to the 5th power. And that'll be fine. It's just a good reminder. But usually I don't require you to do that. Once again, just write that little reminder. Alrighty, and that's it. Let's take a look at the last one for this section. It's going pretty quick. What do we have? We have 5 to the 2 over 3rd power and 5 to the 7 over 3. So if we were going to go ahead and apply what we've been doing before, that would be the 3rd root of 5 squared over the 3rd root of 5 to the 7th power. I don't know about you, but I don't know what the 3rd root of 5 is. So I can't proceed with that. Okay, that plan's not working. Do we have another plan? Well, I could do the other way and take 5 to the 3rd power and then take the square root. And the same thing here, 5 to the 7th power and then take the square root. But I don't know if I want to try to find out what 5 to the 7th power is. Is there another way? Well, notice, you may have noticed it, but the bases are both 5s, which means we can use rules of exponents. So this would be the same as 5 to the 2 over 3 minus 7 over 3, using the quotient rule for exponents. So that'll be 5 to the, so 7 minus 2 is going to be 5, so negative 5 over 3. Aha, and now we know how this works. We have the negative in the top, so let's go ahead and take the reciprocal. So that's going to be 1 over 5 to the 5/3. And now we're still kind of stuck because I don't know what the cube root of 5 is to the 5th power. So I'm going to have to go the opposite direction and do 5 to the 5th power. And then take the cube root. So that's going to be 5 to the 5th power, the cube root. So how can I simplify that? Well, I know there is a perfect cube in there because I can rewrite 5 as 5 to the 3rd power times 5 squared. So that'll be 1 over. I'm going to split the cube roots into the perfect and the imperfect. And then the perfect ones cancel, so I'm left with just a 5. And then the cube root of 5 squared. But now we have some trouble. What's the trouble? We have a radical in the denominator. We're not allowed to have a radical in the denominator, so what do? We need to rationalize it. Okay, so to do that, we're going to multiply this by some number, and my goal is to match this base to the radical. That exponent to the radical. So what do I need to multiply 5 squared by to get 5 to the 3rd power? Well, keep the base, add the exponents. I need to multiply it by 5 to the 1 power, because when I add these two exponents, I'll get the 3. So I'll go ahead and multiply by the cube root of 5. We have to multiply the cube root of 5 as well, because it's the building up property. And then when I do that, I'll get the cube root of 5 in the top, and on the bottom I'll get 5 cube root of 5 to the 2nd power times 5 to the 1st, 5 cubed. And now these guys cancel, and we're left with the cube root of 5 all over. 5 times 5, which is a lot of work. Cube root of 5 over 25. And we are done. Alrighty, that is it for this section. Once again, if you have any questions with any of these, please stop by my office hour or email me to set up another time to chat about these. Once again, my office hours are there to help you out with these problems.